Today's topic is resolution bandwidth filter or IF filter used in the spectrum analyzer. So before understanding it, we need to look at the block diagram of the spectrum analyzer and what role it plays in this block. So on the left is the RF signal that is input, and on the output of spectrum analyzer you can see a spectrum like this, which is power versus frequency. Uh, how this device measures the spectrum is can be understood by this block diagram. So as the RF signal is input, it is attenuated if needed, and then down converted to some lower frequency, and then this whole signal chain converts it to some DC signal, which is sampled by ADC and shown on the display. In the meanwhile, the LO is stepping through different frequencies as set by the user as start to stop frequency, and through each stepping it looks at what amplitude is for each frequency that has been input at the RF signal, and displays it on the graph. So in this whole game, the resolution bandwidth is basically defining the resolution of the spectrum that you can get. So for example, if there is input of two frequencies which are located very near, and if the resolution bandwidth filter is having a high bandwidth, it would show these two different frequencies as a single tone. But if the resolution bandwidth is narrower, it will show little better, and if it's very narrow, you can see the two distinct tones. In another practical example, this is the example in which if you set at 30 kilohertz, you see blue one tone signal, but if you improve the resolution by decreasing the bandwidth, you at 10 kilohertz you can see two peaks, and at 3 kilohertz you can see two distinct frequency tones. So you see, if you decrease the resolution bandwidth, you improve the resolution, and this is basically controlled by this resolution bandwidth filter. The role of resolution bandwidth filter in the spectrum analyzer can also be understood by looking at this video by this guy. So in this, there is a spectrum or the RF signal which is having different frequency components, and if the spectrum analyzer has to measure it, what it would do that it would sweep its resolution bandwidth filter, which is in purple color, over the spectrum like this, and it will keep on repeating the sweep from start to stop, and correspondingly it would measure the amplitude at each frequency as it is stepping through the frequency, and would show the power against each frequency. So I have prepared a MATLAB program to understand this filter better. So let's see over here. So the start and stop frequency of this band pass filter or IF filter is set as 1400 megahertz to 1600 megahertz, which can be seen over here, and its shape is basically set by this selectivity, bandwidth selectivity, and if I change the selectivity of this filter, it becomes more narrow. So so let's just take an example. Maybe there is an IF frequency at 1500 megahertz. So this graph shows the input signal to this filter at 1500 megahertz 0 dB, and at the output of this filter is also 0 dB. So it allows this input signal to pass as it, but if let's say I have another signal at f1 equals 1250 megahertz, which is here, also at 0 dB, when it passes through this filter, it's only left as minus 86 dB. So let's say there was another signal very close to this IF frequency at 1650 megahertz, and again 0 dBm, and when it passes through this filter it's left at only at minus 29 dB. So the idea over here is like, for example, there is one signal center frequency, or you may say one tone is at 1500 megahertz, and which is IF, and maybe another signal which was very near to the our input RF signal, but at maybe 705 megahertz, and the industry standard says that the resolution bandwidth filter should be such that it should provide an attenuation of 60 dB, minus 60 dB. For example, you see here it's 0 dB signal, and when it passes through the filter, the output is around minus 60 dB. So if this condition is met, then the resolution bandwidth filter can resolve these two closely spaced signals clearly on the display of spectrum analyzer. Otherwise, if maybe it was at 1600, it would not have been resolved, because as it passes through the filter, you may see that output is minus 6 dB, and which is already coming under the envelope of this 1500 megahertz signal, so only one peak would be shown on the display. So hopefully it would have made some sense of the resolution bandwidth filter. You can close the app from the exit button, and if you want to experiment yourself, I have added the code on the GitHub. So here it is placed, so you can reach to this link, or it's over here also, and access the code that can be run on the MATLAB over here, and as you hit the run, you will get this app. Hopefully it made some sense. Thank you.